All right, here's your 4.1 notes on exponential functions. Exponential functions is really, I'd say, a review idea for you guys from Algebra 2, at least for the most part. I'll find it to be a review. It's this lead-in to the idea of logarithmic functions, which is really the majority of what this chapter is about. But to understand logs, which is everything that comes after this, you have to really understand exponential because we have to relate the two to each other. And if you understand exponential, that really extremely makes a difference in you understanding logarithmic. So a little flashback to the past in Algebra 2 talking about exponential functions. So this would be a function where the exponent is the variable. And a and x have names. A is what's known as the base. And x, of course, is your exponent. Now you guys have a note sheet to follow along on, so I would follow along on that, try to take notes on that note sheet. Besides just watching the video and listening to me talk about it, it's good to take it down. Okay, so A is your base, X is your exponent. We're going to start by just talking about some graphs. Exponential graphs are pretty simple. You only really need a few points. You need to know what the y-intercept is, which you get by plugging in an exponent of 0. And if you guys think about it, that would make sense. All y-intercepts have an x value of 0. And as an exponential idea, anything to the 0 power is 1. So 0, 1 is your y-intercept unless you have some kind of shifting going on. You have two types of graphs. You have one where your base is a number bigger than 1, which is going to be called an exponential growth. Or you can think of it as an increase as you go left to right. If your base is between 0 and 1, which means a fraction, typically like a half or 2/3 or 3/4, something like that, it's going to be a decay. And it's going to decrease as you go left to right. And we'll explain this with some graphs and some visuals in a second, but it's pretty simple to understand why that happens. Also, because of the idea of exponential, you have an asymptote. What you have going on when you get into the fraction part of your table or fraction part of your values is that they actually approach something but never quite get to it. And think of it as simple as this. If you, let's say, had a base that's 1/2, and you start raising that to really large exponents, well, 1 to any exponent is 1, but 2 to any exponent gets bigger and bigger and bigger. And 1 over an enormous exponent will approach 0, but never gets there. Like, for example, let's say it's 1/2, 1/4, 1/8, 1/16, and so on. So that creates a boundary idea. If there's a shift, which we'll do some shifting a little bit later on in the notes, up or down, that's going to move the boundary line along with it. Some basic ideas: domain. Domain is all real numbers. You can put in anything for an exponent, so there's no limitations on what an exponent can be. Positive, negative, it can be 0, it can be a fraction, it can be just about anything. The range actually is dependent on the asymptote and where you see your graph. For the most part, 0 to infinity, unless your graph is reflected over the x-axis, which would cause that graph to be below the asymptote, and that would change your range a little bit. Horizontal asymptote is at y equals 0, again, unless we have a shift up or down. When we shift graphs up or down, asymptotes move along with the graph. And your y-intercept 0, 1, again, that depends on shifting also, but that's because an exponent of 0 would produce 1 all the time. Okay, there's a basic snapshot of your graph. So what we're going to do is go ahead and just go through some basic graphing, then add some transformations, some shifting onto it. Then we'll do a little equation writing, like from a graph, write your equation, then a few word problems at the end to kind of wrap it up. So let's start out with the basic exponential graph, pretty simple. 2 to the x, start out with some easy exponents like 0, 1, and 2. Anything to the 0 power is 1. Anything to the first power is itself. So that's 2 to the first. 2 squared is 4. Also, one thing you got to remember too with graphing is how do you handle negative exponents? When you put in a negative exponent to a base, you can basically think about it as that turns it into a fraction or as a 1 over idea. So for example, if I have 2 to the negative 1, that's the same as 1 over 2 to the positive 1. And when you do that, of course, you're going to create fractions. So negative exponents actually are dealt with by making them positive and moving them down or flipping your number, flipping your base. But I always say move them down into the bottom of a fraction. So negative 1 is going to give you a half. Negative 2 is going to give you a fourth. And there's the idea of your asymptote starting to develop, because the further you go into the negative, negative 3, 4, 5, and so on, your fraction gets smaller and smaller and smaller, and it approaches 0 but never quite gets there. Now, you really don't need 5 points. I did the negative part of this so you can get a little bit of an understanding of what happens with the graph and why it produces an asymptote. you can do just 0 and 1 as your exponents, and those two coordinates are going to be plenty. What's unique about exponential is the growth part of it, or the increase part of it, is really fast. And you would expect that, because as exponents get bigger, that number raised to those exponents gets really, really big. Okay, just your standard basic graph. We'll do a base that's 1/2, so we can kind of see the comparison. Then we'll go into some shifting ideas, transformation ideas. Again, domain -infinity to infinity, and the range, again, is based on where you see graph. Clearly there's no graph down here. It's all up here, and that makes your range 0 to infinity. Now check out a base that's a number between 0 and 1, so 1/2. And of course what's going to happen here is when you look at the exponents, the ideas are going to reverse or flip. So anything to the 0 power is 1. Anything to the first power itself, when you square a fraction, you square the top, square the bottom. Now go negative. Well, when you take a fraction and you raise it to a negative exponent, that's the equivalent of saying flip it over and raise it to the positive exponent. So if you do that, positive 1/2 to the -1 exponent is really 2. Positive 1/2 to the -2 exponent is really 4. So again, asymptote at y equals 0 because no transformation is going on. Really, again, you don't need that many points. I just like to use 0 and 1, good starter. If you want to do a couple other ones, yeah, you certainly could. I mean, I could go out here and I could do the 2, 4. But when I'm talking about graphing, especially when you're doing shifting, you don't want to shift 5 points. Shifting 2 points is probably a lot easier. And like all graphs you guys have ever done, there's an expectation. You should have an expectation after just looking at the first couple graphs that here's what an exponential growth or exponential decay looks like. They all look the same. There's really no variety whatsoever. So I mean, it's pretty easy to make sure you got the right idea in your head. Okay, again, domain all real numbers, automatic. Range is based on where your graph sits. It all sits above y equals 0 and of course goes up, so 0 to infinity. Well, the next idea would be transformations, and so the same transformations that we've always had exist here. You're going to have a shift left, right, which always attaches itself to x. So you see up in the exponent, x minus h. You have a plus k attached to the end. There's your up, down. Again, these are the same shifts we've had forever, really. That c number out front does a couple things. If it's negative, c, it's going to reflect over the x-axis. That's not a new idea. Make the function negative, reflect over the x-axis. If the x itself becomes negative, then you're going to reflect over the y-axis. And those ideas are the same ideas we had in chapter 2. Okay. So the shifting idea is pretty easy. Now up here in the top of the slide, I've got the basic y equals 2 to the x, so you've got a visual comparison. And again, the points that I'm going to use, just some simple points. I use 0 and 1 as my exponents because anything to the 0 power is 1, anything to the first power is itself. So I can get 2 quick, easy coordinates. Then all I got to do is the transformations. The transformations are simple enough. So down 1. So your asymptote has to move, and so does your graph. So you can see those 2 points have been shifted down 1 from the graph up above. Very simple to do, but when you go up or down, the asymptote has to move along with the graph. Remember, domain's never going to change. Your range changed a little bit because of the downshift. Now we're starting at -1. -1 to infinity. And it's definitely a parenthesis because it's an asymptote that you never get to. So you'll find shifting of these graphs to be really easy. Left, right, up, down, reflections, nothing new going on there. You just got to get used to, get the idea of the exponential graphs back in your head. Couple others, up in the exponent, x plus 3, that's a right movement. So remember how that works, opposite of what you think in terms of sign. Again, I would stick with those 2 basic points as my starting point. You might use little x's. Sometimes that's what I do. I'll use little x's to mark those 2 spots. What I did in my head there was 2 to the 0 and 2 to the first to mark those x's. And then all I got to do is apply the transformation. Those points Going right 3. Remember, asymptotes don't move. This asymptote doesn't move left or right. It only moves up or down. Excuse me, I said right on there. That was my mistake. Clearly it goes left. Remember, a positive is 3 is actually the opposite idea when you're going left or right. So that was my mistake there. Sorry about that. But anyway, going left. And so you can see, counting over 1, 2, 3, counting over 1, 2, 3. The asymptote stays the same. A left-right shift would not change your range. You got the range still being 0 to infinity. Now reflection. So out front of the function, reflection, that's going to be making the function negative or making y negative, reflects over the x-axis. So there's my graph. Asymptote still in the same place. If you think about it, where those two original coordinates were, again, if I mark the spot, there's 2 to the x, and now if I reflect, you can see the reflection going on. Pretty simple. Now, this does change your range because now the entire graph sits below the y-axis, the y-axis, the x-axis, excuse me, or the asymptote y equals 0. So now we're going negative infinity to 0. Okay, so transformations of these graphs pretty simple. Just a matter of you applying the idea of left, right, up, down, and reflection, and that's really all we're doing. We're doing no shrinking, no stretching, so the the transformations are pretty easy to work with. And then here's the last one, making x negative. Now, what making x negative does is causes a reflection over the y-axis. So again, think about your points as just using some simple stuff like those two. The asymptote's going to stay put, and now think about a quick reflection. This point stays the same. This point now moves over here. Asymptote does not move again, no up, down, shift. Domain and range actually don't change on this one. Pretty straightforward. Okay, so there's kind of a quick look through all the graphs and the transformations. Transformations, again, real simple because the graphs are very simple. 2 coordinates is enough to do the job, and if you want to use some x's like I did to mark the starting point and then do the transformation from there, that's usually not a bad idea the first time you do it. Otherwise, I think the graphing idea today is pretty simple. The next thing we're going to look at is equation writing. And equation writing is really about, well, first of all, for equation writing, you got 2 things that you can do. You can just try to look at it and visualize it, which sometimes works okay. I mean, try to just sort of guesstimate a little bit. Other times you can't quite do that, so we need a formula, something to work off of, and I'll show you how that works. But for this one, I bet you could just look at it for a second and figure out what the base is based on the 2 points. So think about it as what number raised to an exponent would produce those coordinates. And I bet if you just think about it for a second, it's not too hard to figure out. Now, you probably won't be able to do it very well based on the y-intercept because that would be the same y-intercept for all bases, as long as the exponent is positive 1. It's the other coordinate that's going to help you. And if you think about how you're getting an exponent 2 producing a base 9, producing a y value of 9, it had to have been a base 3. Now, if you're not sure, just check it out. Of course, it works for 0 because anything to 0 power is 1, but 3 squared is 9, and there you go. Okay, I'm actually going to stop this video, and we'll pick up with a second video to finish the notes.